Now it's time. Okay, great. Welcome to Co-21A. Welcome to the people on Zoom. So there's a couple people on Zoom as well. Welcome to the Zoom folks on Zoom. I will try to not forget about you over there. So Co-21A, you are taking this class because you were also signed up for Math 21A, either with McDonough, however you say his name. Welcome, come on in, or Oberschelp, I think is, yeah, okay, great. Neither of which I'm particularly familiar with, doesn't really matter, but I will try to keep up with what they're doing. I'm on their Canvas pages so I can see what homeworks are being assigned. It looks like in McDonough's class, the homework will be assigned and collected and graded. And also in Oberschelp's class? No, not, he's doing like weekly quizzes, right? And there is homework on web work, but it's not like required. It's just there for you to do at your leisure, which I certainly recommend, right? The more practice, the better. I mean, I did look at the ones he posted. There are a lot of problems there, so I think his advice is good. You should do the ones that like you don't know how to do. If you already know how to do something and you feel confident, comfortable with it, you probably don't need to practice it. But definitely look over the problems, try them. They're not terrible. It's good practice. The more practice you can get, the better. I assume that's why you're here as well, because you know this already. The more practice you can get, the better. The more exposure, the better. So welcome. Excuse me. Did I introduce myself? My name is James, by the way, in case I didn't say that already. Come on in, Julio, have a seat. I would sit somewhere where you're more easily able to see the screen. There are lots of, I know it's hard. I know the seats are challenging to get to. My name is James. You're welcome to call me James. You're also welcome to call me other things like Mr. Parmenter or teacher or instructor or whatever. You could call me professor. I'm not a professor, but people seem to like using that terminology. So if that's what you're comfortable with, totally fine. But James is the best. That's my name and I like it. So you should call me James. Before we get started talking about math, come on in, have a seat. Let's talk about the logistics of the class, of the co-class specifically. So let me pull up Canvas, which is somewhere over here. Yeah, there we go. Cool. Canvas, great. Also, just so you all know, in case you didn't already know, you can change like the names that show up on Canvas for you. I've written here, this is Co-21A, Tuesday, Thursday, 1 to 2:30, and there with the CRN because I wanted to know what it was all the time. But you can change that to whatever you like if you want to, so that you know, I don't know, when it meets, where it meets. You can write the classroom there if you wanted to. I've done that before. But just so you know, this is kind of interesting. Must have spilled some water over here. A little wet. Okay. So Co-21A, let's take a look. Here's really all you need to know about passing this class if you're in a position where you need to pass this class. We'll go over the stuff on the syllabus as well, but really listen to these words. If you are registered for the class, meaning you signed up with the CRN 44, whatever, 184, you probably also got an email from me saying that you were actually enrolled in the class and you need to do these things. You need to do the things, meaning you need to fill out the attendance form and you need to do the weekly reflections. If you didn't register for the class, meaning you got added via Canvas by myself or by filling out a Google form, you don't have to do those things. I would still like you to do those things. Especially the attendance part. I really would like everybody to do the attendance part because we keep track of the students we serve. Small part of that goes towards our funding. Not a huge part of it. We get funded by lots of places on campus, but some small part of our funding is based on how many students we serve. The more students we serve, the more funding we get, the more services we can provide. So please do fill out the attendance form every time you attend class. So those are really the two things you need to know. Fill the attendance form, do the weekly reflections. Yes, I know there was a reflection already due. It's still open until I think the 12th. So if you haven't already done it, which many of you have already done it, thank you. If you haven't, please do it. It's easy. I'm just asking you questions like, what's your name? Where are you from? What math class did you take last quarter? Other not math questions, right? I'm not asking you to do math in the reflection. I'm just asking things about you that are benign and maybe tell me a joke because I like jokes. I'm never good at telling jokes though, which is why I ask you for jokes, because then I can have jokes to maybe tell my wife and make her laugh on occasion. She doesn't usually laugh at my jokes. It's okay. Not everyone has to be funny. So let's go ahead and look at the syllabus part of this. There's some things I kind of feel like I have to say, and then we'll try to get through it. And then we'll talk about the actual useful part of Canvas, which is the modules. But let's go through the syllabus. So you're encouraged to come to class in person. You're also welcome to come via Zoom, especially if you're not feeling well or the weather is terrible or you just don't want to leave your place of residence. Totally fine. Do whatever you want. I like seeing people in person, although I do feel like I'm weirdly disconnected from you all because you're all over the, I mean, not your fault, just I think you should all sit over there so you can see the things that are going to be directed up there. Because the one thing about having class available on Zoom as well is it means I kind of have to do it in this way where I'm projecting things so that you all can see it and also the people on Zoom can see what's happening as well. Also, this means I am recording the class as well. So if you miss class and you can't attend when Zoom is happening because maybe you have another class, you have to study for something, you're welcome to make up an absence by watching the recording at a later date. And we'll talk a little bit more about that in a few minutes. As far as getting a hold of me, the best way to get a hold of me is by email. You're certainly welcome to email me. You can also try calling my office if you really needed to talk to me. I don't imagine anyone is ever going to really need to talk to me. But if you had to and you knew I was going to be in my office, you could call my phone number there and I would pick up. Excuse me. My office is at 2244 Dutton Hall. You're welcome to come see me there if I happen to be there. My office hours are listed right here. Monday, Wednesday, 10 to noon in the library. That'll be starting next week for the library because the drop-in and Shields library doesn't start until I think Sunday. I think it's Sunday. I should double check on that. And then the other office hours here actually have started this week. So I'm available Mondays and Wednesdays from 2 to 3:30 and Tuesdays and Thursdays from 9 to 10:20 in C class or Centro, which is up above the MU. And then I'm available Tuesdays and Thursdays from 2:40 to 4 right after this class in CADS, which is over in the South Silo. You're welcome to come get help. I'll be there just hanging out. I imagine probably no one will come to CADS today. So if you already have math questions, I will be very available today. Grading, I already talked about, oh, I actually didn't really talk about the grading. So you need to do the things to pass the class if you're registered for the class. If you are not registered for the class, meaning you signed up via the Google form or by emailing me, you should not pay attention to the grade you have in Canvas at all. It is meaningless if you are not registered for the class. So don't worry about the grade in Canvas if you are not registered. If you are registered, meaning again, you signed up with the CRN, then you should pay attention to the grade in Canvas. So as far as passing the class, you need a 75% to pass. Your attendance grade is worth 70%. All of you should be showing a 0% attendance grade right now because I went and marked everybody absent for every day. So that then as the quarter goes on, I can mark everybody present for the days they show up. That way, no one will think they have a higher attendance grade than they actually have because I've forgotten to mark people not there, which is it's an improvement for everybody. I think it's going to be a good way of doing it. I know I didn't have any of you last quarter in my co-class, but last quarter at the end, I was like, oh, shoot, I forgot to mark some things not there. And then there was like, what happened? So we're going to do this better this quarter. And then the weekly reflections. They're every week. They're worth 30% of your grades. So if you're looking at the math here, you have to do it. Even if you came every day of class, you would still have to do a couple of the reflections to be able to pass, right? Because 70% does not get you to 75%. There are 10 reflections, 30% total. Each of them is worth 3%. So at minimum, you have to do 2 of them and then attend every day to pass. If you decide that you don't want a unit, don't need a unit, don't care about doing the things that the very easy things I'm asking you to do, you're welcome to drop the class and then get added back just on Canvas and not be registered if that is preferable to you. I'm happy to do that for anyone. But if you need the unit or want the unit because like you're right at 12 units, then you definitely need to do the things so that you pass class. Everyone can pass the class. It's not like, it's not, I know I'm making it sound like it's maybe kind of a big deal. Not that big a deal. Just they're easy things to do. Please do them. If you're absent, you can make up an absence by, again, watching the class later and filling out the attendance form. So let's talk about the attendance form. So I'm going to click on it. Here's what it looks like. And what I would actually like everyone to do, if I remember, yes, is to, if you can, let's see how this works.
See if you can scan that QR code. Let me click here. Let me move you. Cool.
If you're having issues, you can also try. So once you're there, you should be at the attendance form.
And it's not too terrible to fill out. Let's go ahead and take a look just to make sure everybody can do it the right way. So you should write your email address in there. You should write it correctly. I wrote mine wrong. JJ Parmenter. Yeah, I really spelled it wrong. At ucdavis.edu. Please do write your correct student ID number, because later on at the end of the quarter, I actually enter all the student ID numbers into our system for tracking student attendance. And that is actually the one most vital piece of information as far as making sure that we appropriately Have the right data. Please enter your first and last name as your first name first, your last name second. It makes it easier for me, because here's what actually happens. You fill this out, it goes to a Google Sheet. I then go look at the Google Sheet and update the attendance form in Canvas so that you all can see what your attendance grade is. So if you write your name correctly, how it shows up in Canvas, it makes it easier for me to find it when I'm entering the grade, the attendance in Canvas. The class is Co-21A, and the way you attended could be any one of these three. Today, it's certainly live in person, or for the people on Zoom, it is live virtually. And then if you were to watch this class later, like maybe you aren't here today and you decide you want to make up the attendance for today, when you watch this class later and then go fill out the attendance form, you would fill out today's date still. So even if you watch this on the 17th, you're going to still fill out the date as January 9th. And please do enter the 4-digit year, not the 2-digit year, because if you enter just 24, it'll show up as like year 0024. And then sometimes I sort things by year just because I'm looking at stuff, and people are like way up at the top. Why is that person way up? Oh, it's because they wrote 0024, or maybe 2023, or just please try to enter the correct date. It will help me out. You will do this every time you attend class, please. And I would recommend just bookmarking this website so that you don't have to scan the QR code every time or whatever. It's not hard to do. Like if you like hold on the little bookmark thing, and then it'll ask you if you want to make a bookmark. I would recommend doing that. It's not hard. It's pretty easy. Any questions about the attendance form? Okay, I'm going to remind you every class to do it. If I don't remind you, you should remind me to remind you, so that you do it every class. Thank you. I appreciate it. All right, let's see. What else do we need to talk about here? Back to the syllabus about this class. Sure. So if there is something outside of this class that is impacting your success in math, please don't hesitate to talk to me about it. I've certainly had students come to me with professor issues before, which I've been happy to try to help them work out to the best of my ability. Also, something said in the class by anyone, including myself, that makes you uncomfortable, please talk with me about it. Or if I'm the one making you uncomfortable, which I certainly don't intend to be, but if I've accidentally said something that's terrible, please either let me know, or if you don't want to tell me, let someone know, like my boss, so that they can be like, hey, James, I've never had issues at all, but like, I don't know, I could say something stupid. I'm not 100% always great, but I try to be. So if something's causing problems, not that we anticipate this, talk to someone. It's totally fine. I've certainly had students. Well, no, that's a different. I'll get there. There's a different thing I was gonna say, but that's actually back to the impacting your success thing. Just like if there's something I can. Oh, I know. I'm sorry. My brain is like, I know there's something else to say here. As far as accommodations go, if there's something I can do to improve your classroom experience, please let me know. A small thing someone let me know last quarter was that they asked me to use a thicker pen. I like writing in a 0.5 millimeter pen, and they're like, it's kind of hard to read what you're writing. So I changed to a 0.7 millimeter thickness pen, and it really helped. So if there's something that I might be able to do to make the classroom experience just a little bit better or a lot better, let me know. I'm happy to make accommodations, modifications, whatever I can. I'm happy to try to speak a little bit more slowly, but I'm not always good at that. So I'll try my best. As far as back up here, as far as the live class goes, you are here at the right time in the right place. So you obviously know when and where it is. During class, I will try to give you the opportunity to work on some problems on your own or with each other. The hard part about being in a hybrid kind of situation here is that
it can, when I'm recording for a video, it can kind of feel like dead air when I'm just having you work on stuff. So I feel like I am a little bit limited in that way, and that I don't have as much freedom to let you guys work on problems all the time. If it were up to me, I would mostly just have you all, also this classroom, I will admit, is fully not great for what I would love to do, which is like have you all get up on the board and work on problems, but there's too many of you, not enough workspace, so don't think we're gonna get to do much of that, unfortunately. That said, I'm still happy to show examples. I'm going to show you a lot of examples. I'm going to have you work on things. I'm going to ask you to respond to questions, or maybe show me how many on your fingers. I would love for you all to say things, do things, be present, say words. Can I get a yes?
Yeah.
Awesome, great. I love the verbal feedback. What else here? Come to class prepared to work on math problems. That means something to write with and something to write on. You do want to be able to write things down so you can, I don't know, you can't, in my opinion, most math you can't do without writing something down. At least I can't. So come prepared to learn and do things in the way that best suits you. I see most of you have a tablet and thing, or paper and pencil, or paper and pen. Even though I'm writing in pen, I do recommend a pencil for math, but I know that for me, I need to write in pen so that you all can see it better. But I would prefer to use pencil, to be honest. Let's see, what else here? Oh, if you have formal accommodations to the Student Disability Center, please let me know as soon as possible. For this class, it doesn't really make much of a difference because there are no tests, there's no homework, there's no real assignments of any sort. And if you want to record things, you're certainly welcome to, but I'm also recording the class and we'll be posting the video later. So you're welcome to record me if that's something you need or want, but you also don't need to because I will be recording stuff and posting it later. What else? I say a lot. Too many ums. Let's see here. Let's see. Zoom instructions. I think we all know how to use Zoom by this point. And again, you all are welcome to attend via Zoom if that is easier for you. Again, I would like to see you all in person as often as possible, but I get that some days Zoom is just the better choice. Or if you are not feeling well, Zoom is definitely the better choice. So make that choice. Oh yeah, you can use the discussion tab in Canvas. Let's take a look at the discussion tab for a second. I would love for this to maybe actually be a thing. You can ask questions here and anyone can see them in the class. I can also see them and I can answer them or give hints. Like if you have a homework question, I'm like, oh yeah, you should try this. The reason I really like this venue for this is because it is really easy for me to type in nice mathematical typeface. So I can write things that are easy to read mathematically as opposed to just regular type where you're writing like the little caret symbol for the exponent and stuff like that. So if you have a math question and you think I might be able to be helpful, I would love to be helpful in this venue. That said, if you ask via email, I'll probably respond. If you ask a question, I think everybody might want to know the answer to it. I might write an announcement and be like, somebody asked me this and I think you all should know about it. I will not identify you though. Unless you want me to. You'd be like, yeah, I said that. Let's see, back to where we were, which is syllabus. I think we're almost on the syllabus. Which again, there's a lot of information that is really probably not that important in the broad scheme of things, but I kind of feel like I have to go over it. Accommodations, Zoom, some notes, discussion. Each unit in the course is connected to other units. Things will progress. Concepts we'll be covering are hard. It takes time and effort to learn them. And I would say this is certainly true. Successful students are usually spending about 10 to 20 hours per week doing homework, practice problems, studying for the class. Not this class, but for the math one. But this class is just extra studying, extra exposure. I don't think you should be doing any studying for this class. This class is another opportunity for you to get to see the math, ask questions about it, that kind of thing. You can get more help in my office hours from the other AATC math specialists. And you can, if you look at our website here, you scroll down quite a bit, down past all the classes to the office hours. You can see that the other math specialists, Claire, Grant, myself, Jen, and Sarah, all have various office hours that you can attend in various places. Claire's are all virtual because she is in North Carolina. Grant, you can find in Centro from 9 to 11 on Monday, Wednesday, Friday. I'm all over the place. You can find Jen also kind of all over the place, and Sarah all over the place. And also, just for your information, if you are ever taking like stats 13 or stats 100, myself and Jen and Sarah are also all very comfortable helping with stats. So if you're looking for stats help, we are also a good place to find it. Any questions so far? Oh, okay, one more thing. And lastly, you all are a great resource for each other. So you should be studying with each other, getting together, asking each other questions, maybe thinking about what might be on an exam. Definitely studying with other students in your class is probably the best way to learn the material better. Great. I'm having a cord issue over here. I've ordered a new cord, but it hasn't come yet. So eventually, hopefully that won't be a problem when I do that. Any questions about the syllabus so far? If you think of a question later, certainly fine to ask it later. Let's go ahead and look at the modules, because the modules are where you'll actually find the useful information in this class, like the stuff you'll actually want to look at. So right now you are seeing kind of what is the teacher view of the module. So you won't be able to see this course evaluation thing. Later on near the end of the quarter, I'll make this live and I will ask you all to please fill out the evaluation for the course. As far as what you can see all these things in green here. So you can see when my office hours are, a link to the class attendance form, a link to the class Zoom, a link to the 21A playlist on YouTube. This has my videos from the last time I taught the Co-21A class, and it will have the videos from this class available as soon as I post them. And then there's some other short videos I also made for Co-21A that cover just various topics, like maybe a limit here, or I don't actually remember what I've done in there, but they're all fairly short, like 5 to 10 minutes. So, and they are labeled by topic, so you can certainly look at the labels. Oh yeah, I would like to see a video about the squeeze theorem or whatever. I will also link the notes. So whatever I write over here, you can't see me pointing to right now because I don't have that part of the thing up available. But whatever I write over here, I will post to my Google Drive and then link from Canvas. So you can also look at the actual written notes later on if you want to or need to. Grant's website is always a great resource. Let's take a look at it real quick. Right here. You can see lots of notes that Grant has written. I will not lie, I often use these notes as a source of inspiration for examples in this class because they're really good. Lots of great stuff there. There's also extra problem sets and solutions to them. So if you're looking for more practice, but you want practice where you can actually see how it was done after you've done it, it's a great spot. In that, goodness, it's always in the way, always in the way. There we go. In the same vein, how about I just do this? Yeah, let's do that. Great, awesome. Now they're hidden. In the same vein, Kuba's 21A website is also quite useful. He was an instructor here for many years, and he's got lots of homework problems on here with solutions, practice exams with solutions, et cetera, et cetera, et cetera. Lots of practice problems if you're looking for more practice. My website is not worthwhile at all. It just shows my office hours and classes I'm teaching and the picture of my cat. All the good stuff's on Canvas, except for the cat picture. That's not on Canvas. You got to go those except for the cat picture. And then once there are class recordings and written notes, they will go here. And then probably below here, I'll put some practice exams and stuff like that when we get closer to midterms and those kinds of things. All right. Any questions? No questions. All right. Yeah.
Reflections are assigned at the beginning of the week.
Yes. So the reflections, I think, let's double check actually. I think they become available on like Thursday or Friday, but let's take a look. You are in the way. Let's move you over here. Okay. Let's go to the assignments. So the next reflection is available January 12th, which is what? Friday? Yeah, Friday. And it's due on the 13th. Now I know that's a very short window, but it's available for an entire week. So although it's due on the 12th, let's actually take a look at it. Or due on the 13th, apologies. it's available until the 18th. So all of them are due really fast because ideally I would like you to do them at the end of the week so you can reflect upon what has happened in the last week and kind of tell me what, because most of the time I'll be like, what'd you do this week? What'd you learn in class? Give me like a brief 2-3 bullet points as far as what you covered in class over the last week. And then I'll also usually ask you like, what do you want to see happen next week? So ideally you would be doing that on Friday or Saturday or Sunday so that I can see it before I see you all on Tuesday. That said, I know not everybody does everything on the same schedule. That's why you have a whole like 6-7 days to actually do the thing. You don't have to get it done right away on Friday or Saturday, but if you can, I would love that. They're also really easy to do, right? Here's what this next one. What'd you cover in your Math 21A class? The actual class, not our co-class. Your answer can be brief, a few bullet points, a couple sentences at most. What grade would you give yourself in Math 21A this week and why? It's good to have a self-assessment. I like seeing what you think, how you think things are going. Anything you want to see me cover in class on Tuesday or Thursday? This can be general, like limits, or a specific homework problem that you want to see me go over. I will just point out, if you ask for it, you will probably get to see me do it or see me do something very similar. As people often say, the squeaky wheel gets the grease. If you speak up, you're going to get your needs, your desires met. If you're like, oh, I want to ask this question, but I'm not going to, I'm not going to see it. So definitely, if there are things you want to see, just let me know. I'm really, really happy to try to tailor things to whatever everyone's needs are. Let me ask quick, I know I've asked you in the reflection, but quick show of hands, who is in McDonough's class? I hope I'm saying that close to right. Okay, and who is in Oberschelp's class? Okay, so it's 50-50-ish. So we'll definitely have to make sure that we're, hopefully they will not stray too far from each other as the material progresses. Sometimes people stay really close to each other. And they don't. I will certainly try to stay aware of that by looking at their Canvas pages and see what they're doing. But sometimes we might be looking at stuff and it's really just, this is what this person's doing and the other person's not doing it yet, or is waiting to do it later, or might skip it altogether. So sometimes we're going to cover things that might not be going on in your own class. Still worth seeing. And then I usually ask some sort of question about something like a book you've read, or here I have, what was the most interesting thing you learned in one of your classes last quarter? That seems like a good question. We'll see. I'll see what the answers look like. So the reflections are easy, right? Take you 5 minutes, 10 minutes at the most. Don't spend more than 10 minutes on it. I'm not asking you to spend a whole lot of time on this. I really just want to quick, like, what'd you do? What do you want to see? What's going on? How you feeling about class? That's the point of these reflections. They're not to like make you do any work. All right. Yeah, good question. Thank you. Other questions? Supposed to like wait when I ask that, but I don't want to wait because I want to do math. Let me ask you all. Let's see. So I know McDonough posted something or whatever, said you guys didn't like, he just covered class logistics yesterday, didn't like do any math, right? Does that sound right? Okay. What about in Oberschelp's class? Did you guys do any quote unquote math? What did you guys talk about? Okay, that's pretty typical. So I will say most of the time, and it'll depend, but like I was looking at the syllabus for this class, you know, syllabus is like review chapter 1 lecture, sections 1.1 through 1.6. Review chapter 1, cover different definitions of exponential functions and logarithms. Okay to skip and refer to as needed. I mean, yeah, I guess, but like, it's not really okay to skip all that. That's a lot of stuff. And not everyone has seen all the things all the time. So I guess I should ask you all. Let me just, and also, this is also for the people on Canvas. If you have things you want to say, you can write things in the chat. I will see it. I might not see it right away. And maybe one of the students will point out to me, oh, James, there's a chat. And I'll be like, okay. But if you have things you want to ask, you can also unmute yourself. You might scare the living life out of me, but you can unmute yourself and say words. But chat's probably the best. What kind of pre-calculus or even calculus topics should we start talking about? I have a few ideas, but if anyone has any requests, now's your moment. Yeah. Trey, I was hoping you would say that.
Cool. What else? There are other things besides trig. I love trig, so I can talk about trig all day. Yeah. Derivatives. Okay, we're not going to get there today, but that is definitely coming up. Cool. Yes. Logarithms. Logs. Other things? I can think of two more things that I would put on this list. Yeah. Yes. Oh, excellent. Love it. These slides. Yeah, exponential. That's the thing I wanted to do with log and power. Yeah, power function too. Power. What power? Oh yeah, power. There's something in my mind. Oh, I know what I was thinking. Domain. That definitely should talk about. And I guess also other things. I think are there other things. Feels pretty good. Okay, this we're gonna save for later. The other things, where do we start? I say we start here first, because that's where I want to start. We'll talk about trig. We'll see if we get the logs and exponential. Oh, piecewise too. Yeah, we can probably throw this in all over the place. Cool. Seems like a good place to start. All right, domain and range. Okay, what time? What time we end it? What time? 2:30? Sounds right, I think. Yeah, let's look at the syllabus and see. Let's see here. Yes, we meet from 1 to 2:30. Awesome. Okay, cool. Good. That's what I thought, but it's always good to make sure. Let's do that. Let's do that. Everyone can see all the things. Also, just so you all know, my handwriting is, I would say, mediocre. It's fine. It's usually pretty legible. If something is not legible, please let me know. I'm always happy to clarify. I'm going to risk moving this down just a little bit. Sometimes my 4s look like 8s. So just let me know if something's unclear. I'm happy to. And I'll try not to write too small, but sometimes I'm like trying to squeeze stuff into the bottom. So I will make my very best effort to not do that. And yeah, I will see. So let's see here. Let's talk about, oh, I've got some notes I want to refer to just because they're good notes. Let's talk about domain and range for a moment or two. And then we'll get to trig. Yeah, I like trig. So domain and range. Let's look at this function here. Well, let's look at this piece of a function. Let's say we're starting here. I'm going to label a few things in a moment. Let's say that this is our entire function, and this is the point 1, 2. And this at the top here is the point 3, 8. And over here we have the point, well, we almost have the point 7, 4. So just looking at this picture here, and again, let me take a quick look. I want to just make it. I mean, not that I have a whole lot of options here. Let me just look too awful. Yeah, it could be better, yeah, but I guess that's pretty much always true of the visuals here. So let's talk about the domain. So the domain is all possible x values, all possible inputs. So all possible x values. So looking at the x values that are showing up on this graph, the lowest x value I'm getting is 1. I can go as low as 1. So x is bigger than or equal to 1. I'm going all the way up to almost 7, but not quite 7. I can get as close to 7 as I want, but I'm actually not getting the value of 7 because that's an open point there. So I would say x is bigger than or equal to 1, less than 7, not less than or equal to 7. And that's one way of writing the domain, but typically, when we write domain and range, we often prefer to use what is known as the interval notation. So I would probably write the domain as the interval from 1 to 7. A bracket to include the 1, a 7, and the parentheses to exclude the 7. Everything up to 7. Everything 6.9, 6.999.
et cetera, et cetera. Any number as close to 7 as you want, except for 7 itself. So the range, the domain, all possible x values. The range, all possible y values. So, show me on your fingers. How low do the y values go? On the fingers. This thing. The y values go as low as 2. And I could ask you to show me on your fingers, but I'll just say we go as high as 8. Right? I mean, that's a lot. You could do it, but it's a lot of fingers. And we aren't missing any y values in between. Right? You get every y value from as low as 2 to as high as 8. So our range here is everything from y being bigger than or equal to 2 to less than or equal to 8. Or we could write it as the interval from 2 to 8 with brackets on either end. So we're getting every y value between 2 and 8. And yes, 8 is included because we get that point up there. It might feel a little confusing, like why aren't we missing something at the end? Well, because we have all the y values between there and there, even though, right, we're not getting the value of 4 here, but we're definitely getting the value of 4 here and here. So we're not missing anything in the range, at least between 2 and 8. That's kind of a contrived example, right? That usually you're not kind of encountering just pieces like this. You might have something that's more like, in fact, let's look at a piecewise function. Let's look at something like the following. F of x equal to 1 minus x squared when x is less than 0. Think for a second now that I'm sure, and we'll do, yeah, let's do that. And yeah, x plus 3 when x is greater than or equal to 0. And I have no idea what the range is going to be here. But I know what the domain is. The domain is everything. There isn't an x value I'm missing, right? We're defined to be this piece when x is negative, and we're defined to be this piece when x is non-negative. And both of these functions, 1 minus x squared and 3 plus x or x plus 3, both of those are defined for any value of x. They don't have any restricted domain issues. So we can probably confidently say our domain is going to be everything. Negative infinity to infinity. Another way you could write this, which some people like to do because they feel fancy, is they write it as a fancy R. It's just an R with 2 vertical lines instead of 1 vertical line. That also means all real numbers. But I would write it as everything from negative infinity to infinity. That's my preferred way of writing it. I don't know what the range is, and I can't really know what the range is unless I graph it. Sometimes, we'll talk about this later on, there are methods of finding the range of some functions based on finding the inverse function, but for now, I would say it's easiest, or really kind of the only way we can find the range currently is just by graphing. So let's graph this thing. Okay, so when I'm graphing a piecewise function, I don't always actually do this, but I think about graphing each piece completely and then kind of coloring in the parts of each piece I need. So 1 minus x squared, that's a downward opening parabola that's been shifted up by 1. It's got a y-intercept of 1, and it looks like this. I would also point out it's got x-intercepts at 1 and at -1. But really what I thought about doing was taking x squared, flipping it over, making it negative x squared, and then adding 1 to it and shifting it up by 1. That's how I'm graphing this in my head. So here's y equal to 1 minus x squared. And then for y equal to x plus 3, that's a line. When I graph a line, there are 2 things I look for. I look for the y-intercept and I look for the x-intercept. The y-intercept I get by setting x equal to 0. If x is 0, what's y going to be? Definitely 3. And then to find the x-intercept, I set y equal to 0. So in fact, y-intercept, right, x is 0, y is 3. X-intercept, if y is 0, what is x going to be?
let's see, 0 equals x plus 3. So negative 3 is equal to x. So there's the line. And then I like to think about which parts I have. So I'm going to have 1 minus x squared when x is less than 0. That's to the left when x is less than 0. So I want all of this up to that point and none of that. Similarly, over here, I want the graph of x plus 3 when x is bigger than or equal to 0. So I want everything over here where x is bigger than or equal to 0. I want all of this and none of that. And then I graph those two pieces that I want on the same coordinate axis system. So here's my actual piecewise function. I'm going to kind of note the important points here. 0, 1, although it's not actually a point on my graph, is still worth noting. And the point 0, 3 right there is also worth noting. So I want all this to the right. So it's going to look kind of like that. And then to the left, I want this piece here. So I want this open point here at 0, 1. And then it's going to go down like that to the left. I didn't label that very well. Sorry. So I've got a closed point here at 0, 3 and an open point here at 0, 1. And now we can talk about the range. Bless you. So when I talk about domain, I think about going left to right. How far left do the x values go? How far right do the x values go? Here, domain, the x values go all the way to the left, and I'm not missing any x value from left to right. For the range, I do the same kind of thing, except instead of left to right, it's bottom to top. So how low can we go? Sounds like we're going to limbo. How low can we go? Yeah, all the way down to negative infinity. And then we go up, 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 and then we have to stop at almost at what? At 1, right? Definitely at the y value of 1. So our range is looking like everything from negative infinity to 1, but not including 1 because we don't actually get 1. And then we're going to start back up at what y value? 3. And we do want to include the 3. So it's going to be negative infinity to 1 exclusive, union 3 inclusive, and then it just goes up and up and up and up all the way to infinity. So there's our range of this piecewise function. I think if there's anything else I really want to say about this. I don't think so. Okay. Yeah. Domain and range. Let's say a little bit more about domain. What time? We end at 2:30. 2:30. Okay, got 37. Awesome. Okay, let's talk a little bit more about domain because I want to say that there's probably 3 things you really other than knowing that domain is the possible x values and range is the possible y values. There are 3 specific types of domain things you should be aware of, or 3 kinds of functions that have domain restrictions. So, domain restrictions. One type of function that has a domain restriction is some sort of fractional thing. You call it a quotient, you call it a rational function, something that might look like this. F of x equal to 6 plus x over x squared minus 5x plus 6. Yeah, that'll work. This function, there are some values of x that are not in the domain because there's some values of x that make us divide by 0. We're not allowed to divide by 0. So here I'm going to think about excluding the values that make the denominator equal to 0. So I'm going to set x squared minus 5x plus 6 equal to 0 and find out what x values satisfy that. Often we'll be able to factor this. If you couldn't factor this quadratic equation, how else could you solve it? Yeah, you could use the quadratic formula. You don't have to here though, because this definitely does factor. X squared minus 5x plus 6 factors as x minus 2 times x minus 3.
right? -2, -3, multiply to 6 and add up to -5. So we're good to go here. So my solutions here that I want to exclude are x equal to 2 and x equal to 3. So here, our domain, if we look at the number line, everything on the number line except for 2 and 3. I want everything else. I do like drawing it. I find it helpful. Writing it in interval notation, it's going to be everything from -infinity up to 2, parentheses, union 2, comma 3, parentheses, union, parentheses 3, comma infinity. I'm just pulling out a couple points that I don't want, and everything else is in the domain. And that's pretty standard when you have a fractional type thing like this. You're just removing the few points that make the denominator equal to 0. Type 2. I guess I could number these things. 1 and 2. You might have an even root, like a square root, or a fourth root, or a thousandth root. For example, g of x equal to the square root of 16 minus x squared. First and foremost, it's not equal to 4 minus x. Right, we can't square root each part because we're connected by a subtraction sign here. If it was the square root of 16 times x squared, it would totally equal 4x with some weird caveats. But when you have subtraction inside of a root, you're kind of just stuck. It is what it is. This one, I might even talk about the range as well because it's kind of neat. Here, the domain, well, we know we can only take the square root of non-negative numbers. Right, we can't take the square root of a negative number. Yes, there's this whole thing about like imaginary numbers and complex numbers. We're not dealing with that. When someone says or asks about the domain of a function, the implied question there that they're not saying is, what's the domain of this function so that whatever you put in gives you real outputs? So you have to be able to put in numbers so that whatever you get out is a real number, not an imaginary or complex number. Those are off limits as far as outputs for functions are concerned in this class. So here, we're going to set the insides to be greater than or equal to 0. And I would really, really, really not recommend bringing the x squared over to the other side and taking the square root of both sides. It's a recipe for making errors. Typically, when you're trying to solve an inequality and you have powers of x that are other than the first power, if it's linear, like if you just have x to the first, you can typically just solve for x. You have x squared or x cubed or the square root of x or other powers of x. You usually want to leave that 0 on its own and try to factor the other side if you can. Factoring is usually the way to go when solving equalities or inequalities. So I'm going to factor this as 4 minus x times 4 plus x. And then the only way to really deal with this is to use a number line. On my number line, I'm going to put all the values that make this expression equal to 0. Or undefined, but there are none that make it undefined. So one value that makes this left-hand side equal to 0 is what? Everybody. Thank you. And somebody else, what's the other value? Thank you. Right, those are the values that make this expression equal to 0. And the places where it's equal to 0 are the only places where it can change signs from positive to negative. Right? If you go from positive to negative, you either had to go through 0 or you had to go through being undefined. And since this isn't undefined anywhere in this interval, we are just saying, oh, well, then it had to go through 0. So let's pick a point over here. Let's say x is equal to 7. 4 minus 7 is negative. 4 plus 7 is positive. And the negative times the positive is, yeah, so it's negative over there. It doesn't matter if it's 70 or 70 million. 4 minus 70 million is also negative, and 4 plus 70 million is also positive, and a negative times positive is still negative. You could have picked anything bigger than 4 and gotten the same result. Between negative 4 and 4, I'm going to pick 0 or 1. 4 minus 1 is positive. 4 plus 1 is positive. Positive times a positive is positive. Over here on the left side, picking something like -6, 4 minus -6 is positive. 4 plus -6 is negative. And a positive times a negative is still negative. Notice through that whole process, I never actually said what anything was. I didn't say 4 minus -6 was 10 or 4 plus -6 was -2. So I didn't care about the values. I only cared about the sign. I was trying to do less mental work because I don't need to do that work. I don't need to spend my mental energy doing those calculations that aren't really important if I just care about if it's positive or negative. Now, the important question is, which parts do we want? Do you want the parts where it's positive or the parts where it's negative? Positive. We want the parts where it's greater than or equal to 0. So we want all the stuff between -4 and 4. So here our domain is bracket -4 to +4. You can certainly plug in 4, right? 4 squared is 16, 16 minus 16 is 0, and the square root of 0 is 0. I should also point out, because I think it's worthwhile, this function actually has a shape that you should be, or that you will be, familiar with. It might not look super obvious written as y equal to the square root of 16 minus x squared, but if you square both sides, and then add x squared to the left-hand side, this equation might look familiar. What kind of graph does this equation have? It's a circle. It's a circle centered at the origin with a radius of 4. Now, the only difference between this equation and this equation is this equation down here, you get the entire circle. X can be positive or negative, y can be positive or negative. Up here, when you take a square root of something, you only get what kind of results? Positive. I want to say that again. When you take the square root of something, you only get what kind of results? Positive. Technically, I should say non-negative because the square root of 0 is 0 and 0 is not a positive number. It's a non-negative number. It's also a not positive number. But here you only get y being non-negative, so you only get the top half of this circle of radius 4. This thing's a little, that's interesting. This thing I'm writing on is not super solid or set. But looking at this circle with a radius of 4 that has points at 4, 0, and 0, 4, and -4, 0, you can certainly see the domain is -4 to 4. You can also see that the range, the y values go as low as 0 and as high as 4. One more domain question, then we'll move on to some trig stuff, I think. And then logs and exponential probably next time. So last domain thing for now. Let's say that our function was h of x equal to the log base 2 of, yeah, we'll do that. X minus 4 cubed times x plus 1 squared. So similar to square roots or even roots. Oh, actually, let me back this up for just 1 second. You don't need to write this down, but I just want to point out one quick side question. If my function was the cube root of 16 minus x squared, the domain would be all real numbers. Because we can take the cube root of any number, positive or negative. It's not always pretty, right? The square root of 3 is not a nice rational number. It's 1.73 something, but it's still a real number. In the same sort of way, the cube root of anything is always going to be a real number. The cube root of 8 is 2. The cube root of 9 is 2 point something. The cube root of -8 is -2. Because -2 times -2 is 4, times -2 is -8. And in a similar gross way, the cube root of -9 is -2 point something. In fact, let's see what the calculator says. -9. Ooh, gosh, I can't even see what's, oh my God, my calculator is terrible. Can't see anything on this. -9, the cube root of that's going to be, let's see. I did it wrong. Sorry, I'm not smart with my calculator sometimes. Let's be smarter about this. It's a terrible device I'm using here. It's so ancient. The cube root of -9 is about -2.08008. Cool. I didn't know that. I mean, I knew it was a -2 point something, but I didn't know what it was. So cube roots, fifth roots, any odd root, you take the odd root of any positive or real number. But even roots, square roots, fourth roots, sixth roots, etc., the domain is restricted. The insides or the argument has to be greater than or equal to 0 all the time. And in a similar way, logarithms have a similar restriction, except you can't take a log of 0 as well. So for logarithms, the domain or the stuff you're taking the logarithm of has to be strictly greater than 0. So here, if I was trying to find the domain, I would start off by saying all the stuff inside the logarithm or in the argument of the logarithm has to be strictly greater than, not equal to 0. And yes, this kind of bears more discussion as far as like, what is a logarithm and how does it work and all that stuff. But for now, we'll leave that till next time. So solving this, I'm doing the same sort of way as I just did for the previous problem. I'm going to put on my number line all the values that make this expression equal to 0 and or undefined. Here, my values are +4 and -1. And you can, well, the first part we still do the same way. I'm going to test a point. I usually like to start as far right as possible. That's just my personal preference. You can start to the left, you can start in the middle, it doesn't really matter. I like starting to the right. I don't really know why, just probably how someone taught me how to do it. So pick a number larger than 4, like 16. 16 minus 4 is positive. A positive number cubed is still positive. 16 plus 1 is 17. I'm doing too much mental work. 16 plus 1 is positive. Positive number squared is still positive. So the whole thing is positive. Now here's what I want to point out. You could keep doing this. You could test a point between -1 and 4, right? You could test 0. 0 minus 4 is negative. A negative number cubed is still negative. 0 plus 1 is positive. A positive number squared is still positive. So a negative times a positive is going to be negative. Or you could do something slicker. You could say, oh, this 4, it came from that factor. That factor has an odd power. When the power is odd, the sign changes. Let's do it again, and then we'll go back and look. This -1 came from there, and it has what kind of power? Which is odd or even? Even. When the power is even, the sign stays the same. Let's see why. So between -1 and 4, I plugged in 0. I got, so actually, let's go back. In fact, let's look at the whole picture. So let's look at x minus 4 and x plus 1. Yeah, we'll do a whole thing here real quick. I know it's kind of tedious, but it's fine. So when you plug in a number bigger than 4, x minus 4 is positive. Between -1 and 4, x minus 4 is negative. Between or less than -1, still negative. When you plug in a number between bigger than 4 for x plus 1, positive. Between -1 and 4, like 0, still positive. Less than -1, like -2, negative. But then you're raising this to a third power and this to a second power. A positive number cubed is still positive. A negative number cubed is what? Still negative. A negative number cubed is still negative. A positive number squared, still positive. Still positive, but a negative number squared is still positive. So here's the deal. Odd powers retain the sign of the thing they are the power of. If you have a positive number to an odd power, it stays positive. If a negative number to an odd power, it stays positive. A negative number to an odd power, it stays negative. Whereas anything to an even power ends up being positive, right? -5 squared is positive 25. Positive 3 squared is positive 9. So the odd powers capture the change in sign. The even powers do not. So when you have an odd power and the inside is changing from positive to negative, the whole thing changes signs. Whereas when you have an even power and the insides change from positive to negative, you don't end up changing the overall sign because the overall sign didn't change because even powers the sign stays the same. That's really why that works. So this is a faster way of doing it. Say, oh, the 4 came from here, odd power sign changes. The negative 1 came from here, even power sign stays the same. We don't want the endpoints because we want it to be greater than, not equal to 0. So here our domain is just everything that is bigger than 4. Cool. I feel like there's something else I wanted to say here. No, probably not. Do want to say one. So one more thing before trig, just because this is something that comes up a lot. I'll ask you all a question. If I were to solve, in fact, I want you all to solve x squared equal to, sure, 25. Should be fairly quick work. You don't even have to write it down if you don't want to, but you could. My solutions are going to be, and yes, solutions, plural. What are my 2 solutions here? Yeah, plus or minus 5, 5, or negative 5. Okay. There is a point to this. It's not just to ask you questions. What's the square root of 25? Just 5. Not plus or minus 5. Okay. Well, what's the square root of 5 squared? Yes, I'm repeating myself. I know. Please just humor me for a minute. Square root of 25 or square root of 5 squared? Okay, cool. All right, one more time. What's the square root of negative 5 squared? 5. Just good old 5. Okay, here's the reason I'm asking you this. What's the square root of x squared? Not just x. What if x was negative? It's x half the time. And the other half of the time it's, what is it? So let me ask you, if I put in 5 and I get out 5, cool. If I put in negative 5 and I get out 5, it's kind of like the absolute value. It's not just kind of like, it's exactly all the time like. The square root of x squared, and I did definitely ask it in a kind of tricky way. I expected you guys to give me some wrong answers, which I appreciate. I appreciate the bravery. I will admit, and maybe this is not my fault. Sometimes I'm going to ask you things leading you towards a wrong answer to help you see it. And for that, I kind of apologize. I don't really feel that bad. I'm not going to lie. But because I'm trying to get you to see a big thing. And the big thing here is that the square root of x squared, not just x, which is annoying. It's actually super annoying. I wish it was always just x. But sometimes that's going to be important to see the absolute value of x, especially because people ask you weird limits some of the time. And it's just like, and you have to use that piece of information. Other things too, yeah.
If there's parentheses on x, would it just be x or would it still be up?
If there's parentheses, like if it was the square root of, oh, like if it was like this.
No, like the x itself has parentheses like that, -5.
Like that there?
Yeah.
It'd still be opposite value of x, yeah. On the other hand, just to kind of go the other way for a second, it is true that if you have the square root of x and then you square it, well, if you're taking the square root of x, x already has to be what? Non-negative. Oh, good. I like the non-negative. I would have accepted positive as well, but non-negative is the technically more correct answer. And so since x is already positive and then you square it, you're still going to get a positive number. This is just x, but you're limited to x being greater than 0. So, interesting piece of information. The square root of x squared is actually the absolute value of x. And this does come up a bit more often than you would actually imagine. Yeah. Okay, let's talk about trig for the next 15 or so minutes. There's so much to say about trig. Where to begin? Where to begin? Let's talk about the trig graphs. Trigonometry. Is that really where I want to start? Let's start with the unit circle. I'm like, where should we start with? There's so much to say. I feel like I don't even know where to begin. But let's start with the unit circle here. So looking at the unit circle for just a moment. When I think about the unit circle, which is a circle of radius 1, so this endpoint here is 1, 0, this endpoint here is 0, 1, this endpoint over here is -1, 0, this endpoint down here is 0, -1. By the way, I often terribly refer to these as the 4 corners of the unit circle. Yes, I know circles don't have corners, but it's the easiest way to say it. So these are the 4 corners of the unit circle. They're really useful because, well, in the unit circle, we draw a segment there. Call this angle theta is the typical notation. Drop a perpendicular. This length here, I'm going to call X. This length here, I'm going to call Y. This point here, I'm going to call X comma Y. The radius of the circle is 1. So the hypotenuse of that triangle is 1. And we can say that sine of theta, which is the opposite over the hypotenuse, is equal to Y over 1, which is just Y. So in the unit circle, the Y coordinate is the value of sine of the angle. And in a similar way, cosine of theta is the opposite, not the opposite, James, the adjacent, oh geez, I forgot my SOHCAHTOA already. SOHCAHTOA, right, CAH. Cosine is the adjacent, wow, which looks terrible, over the hypotenuse, which is going to be, the adjacent side is X, the hypotenuse side is still 1, that's X. So these coordinates give you the cosine and sine value. Which one is first? The one that comes alphabetically. X before Y, cosine before sine. That's how I like to remember it. Tangent is the opposite over the adjacent. It's also the sine over the cosine. It's the Y over the X. These are the 3 trig functions I remember. The other 3, I only remember as reciprocals of these 3. So if you're trying to memorize values or definitions, remember these 3 and then write the other ones next to them. The reciprocal of sine is cosecant. That's cosine right there. So, and yeah, the names are not the best. But when 2 things have, like sine and cosine are cofunctions, secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. Reciprocals, I don't know why they picked the names the way they did, but yeah, the reciprocal of sine is cosecant. It's literally the reciprocal. So instead of opposite over hypotenuse, it's hypotenuse over opposite, which is 1 over Y. The reciprocal of cosine is secant of theta. It's hypotenuse over adjacent, which is 1 over X. And finally, cotangent of theta is the cofunction of tangent. It is also the reciprocal of tangent. So cotangent of theta is the adjacent over the opposite. It is the cosine over the sine. It is the X over the Y. Now, what do I use this for? I use this particular picture to find cosine, sine, tangent of angles like 0 radians, or pi over 2 radians, or pi, or 3 pi over 2, or 2 pi. Yes, we could say them in degrees, but you should get comfortable with radians because your teacher's probably going to use radians the majority of the time. Not exclusively. People will definitely go back and forth between radians and degrees as willy-nilly, but the default is probably radians. Not probably, the default is radians. So for example, if I wanted to find sine of 3 pi over 2, I would look at the angle 3 pi over 2 and say, oh, it's going to be -1. Or cosine of 3 pi over 2 is 0. Or tangent of 3 pi over 2 is -1 over 0, which is undefined. Sometimes that happens for these angles.
And then I can find all the reciprocals as well. Cosecant of 3 pi over 2 is 1 over -1, which is -1. And secant of 3 pi over 2 would be 1 over 0, which is again undefined. And cotangent of 3 pi over 2 would be 0, would be the x over y, the cosine over sine, which would be 0 over -1, which is 0. So that's what I might use this picture that I like to draw, is to find the trig functions of these, what do we call quadrantal angles, the ones that occur on one of the axes. Those are not the only angles though. So time. What other angles should we know about? There's at least 3. Oh, can I maybe make this look straight? Sure, okay. How should we look at these other angles? You can look at them on the unit circle. So there's probably 4 good ways of memorizing things about angles in trigonometry. And I don't pretend like any one of them is better for you or for me. You should do what works best for you. I would say you can either memorize what's going on in the unit circle, or you can memorize some triangles. Or you could not do either and look it up and hope that there's not that much trig in the class. I don't know. Like, I mean, really, like, you have options. Not everybody likes trig. Trig can be, no, I mean, I think trig is one. I like trig a lot. So here's 2 ways of looking at other angles. So we can look at a square whose side length is 1. And then we're going to cut it in half diagonally. So now I've got a triangle, a right triangle, where this angle is 90 degrees or pi over 2 radians. And these angles are both 45 degrees or pi over 4 radians. These 2 sides are still 1. And we're going to find that third side using the Pythagorean theorem. So if I call it, I don't know, x for a moment, 1 squared plus 1 squared equals x squared. So 1 plus 1 is 2. And the square root of 2 is what x is equal to. Yes, technically there are 2 solutions to that equation. X could be plus or minus the square root of 2. But since we're talking about a physical length, we should think of it as a positive value. So this side is going to be the square root of 2. And then I can use the normal SOHCAHTOA kind of things to find sine, cosine, tangent of this angle. So sine of pi over 4 radians is root 2. Oh, I'm getting ahead of myself. Is 1 over root 2, which I would rationalize as root 2 over 2. Cosine of pi over 4 is also 1 over root 2, which I would rationalize as root 2 over 2. Just to make sure everyone's on the same page here, when I say rationalize, I'm just taking my 1 over root 2, and I don't want an irrational number in the bottom, so I'm multiplying by root 2 over root 2 to get root 2 on top, and the square root of 2 times the square root of 2 is just 2 on the bottom, just in case that wasn't clear. And then the rest, we can find tangent of pi over 4, which is the opposite over adjacent, which is just 1 over 1, which is 1. And that's really all I'm thinking about. The other 3, I'm not really thinking. I'm just looking and flipping and writing. So for example, when I look at cosecant of pi over 4, I'm not really thinking, oh, it's hypotenuse over adjacent. No, it's not. I can't even think of it right. It's hypotenuse over opposite. I'm not really doing that. I'm saying, oh, well, there's sine. It's 1 over the square root of 2. So cosecant is the square root of 2 over 1, which is just the square root of 2. That is, in my opinion, the easiest way to find any of the 3 reciprocal trig functions, is to find the original one first. For secant, it's going to be the same deal. It's going to be the reciprocal of that, which is root 2 over 1, which is just the square root of 2. And for cotangent, the reciprocal of 1 is still 1. So cotangent of pi over 4 is 1. You can do that, or you could memorize this part of the unit circle. Say, oh yeah, for pi over 4, the point there on the unit circle is root 2 over 2, comma, root 2 over 2. and say, okay, well, cosine is root 2 over 2, sine is root 2 over 2, tangent is that divided by that, which is just 1. And then all the reciprocals. I don't know what way is best for you to memorize it, but you should definitely figure out what is best for you and do that. What time is it? Okay. Let's look at the last two, and then I think we can say something about a nice little pattern here. So there's two more. We're going to find the following way. Here is an equilateral triangle. The side lengths are all 2, because that makes it easier. The angles are all 60 degrees or pi over 3 radians. So there's a pi over 3. There's a pi over 3. And I'm going to cut this in half. And half of pi over 3, or half of 60 degrees is 30 degrees. 30 degrees is pi over 6 radians. So I look at this triangle with a pi over 3, pi over 2, and a pi over 6. Also normally referred to as your 30, 60, 90 right triangle. But I'm digging the radians, but it is 30, 60, 90. The side lengths are still 2 here. We cut this side in half, so that's a 1. And to find this side, we're again going to use the Pythagorean theorem. 1 squared plus x squared equals 2 squared. X squared equals 4 minus 1. X equals the square root of 3. So then we can use this triangle to find the trig functions of the other two quote unquote important angles. Pi over 6 and pi over 3. Let's write down the 3 primary ones. Sine of pi over 6 is opposite over hypotenuse, 1/2. Cosine of pi over 6 is adjacent over hypotenuse, root 3 over 2. And tangent of pi over 6 is opposite over adjacent, which is 1 over root 3, which we should rationalize as root 3 over 3. And then we could fill in the reciprocals. Cosecant of pi over 6 is 2 over 1. Secant of pi over 6 is 2 over root 3, which rationalizes as 2 root 3 over 3. And finally, cotangent of pi over 6 is root 3 over 1, which is just root 3. The thing that I think is kind of fun, fun might be an oversell there. The thing that's interesting is that for the other important angle, pi over 3, we're going to get the same values. They're just going to get all interchanged. So I look at sine of pi over 3. Well, now I'm looking at that angle. The opposite side is root 3. The hypotenuse is still 2. So it's root 3 over 2. And cosine of pi over 3 is 1/2. And tangent of pi over 3 is root 3 over 1. And then we have all the reciprocals again. Cosecant of pi over 3. Well, I know that 2 over root 3 becomes 2 root 3 over 3. Secant of pi over 3 is going to be 2. And cotangent of pi over 3 is going to be 1 over root 3, which rationalizes this way. So those are probably all the angles you're expected to know the trig functions of. Yes, we could extend that to other quadrants, but I feel like we don't really need to go there just now. What I want to say about these two angles, pi over 6 and pi over 3, or 30 degrees and 60 degrees, is that if someone says find sine of 30 degrees or sine of pi over 6 or whatever, you should know right off the bat it's either 1/2 of root 3 over 2. That's the place I've got. And I honestly, that's usually as far as my brain always is. My sine of 30, like 1/2 of root 3 over 2. Okay, 30 degrees is the smaller angle. And for the smaller angle, the sine value is the lower value because it's further right than it is up. And the sine is the y and the cosine is the x. So the lower value, well, which is lower? 1/2 or the square root of 3 over 2? Well, which is smaller? 1/2, 1 over 2, or the square root of 3 over 2? What's smaller, 1 or the square root of 3? 1. So 1/2 is the smaller of 1/2 and square root of 3 over 2. So I know because
30 degrees or pi over 6 is the smaller angle, sine is a smaller value. Similarly, for 30 degrees, cosine is going to be the larger value because, again, I've moved further to the right than I have moved up. And then it's flipped for the pi over 3s, right? For pi over 3, the y value is the larger value, the x value is the smaller value. I guess we're out of time. So Thursday, we'll probably talk a little bit more about trig. Specifically, I think the graphs of the sine and cosine function, probably also tangent, cotangent, secant, and cosecant, just so you can see them. And then we'll delve into talking about logs and exponents and power. Seems good. And then we'll probably start, if we get through all that, which maybe, then we'll start talking about limits, because that's where you're definitely all going to be very soon. It's talking about limits. The limits are not terrible. You're just talking about what happens to a function as x gets really, really close to some number.